Once upon a time, in a far-off land, there lived a witty robot named Robbie. Robbie was no ordinary robot, oh no. He was as sharp as a tack and as quick as a whip. Robbie had a twinkle in his LED eyes and a shiny silver body that gleamed in the sunlight. His nimble metal fingers could pick up anything from a tiny screw to a hefty toolbox.
New videos every day. Subscribe to our channel.
Robbie's world was a place of wonder, filled with all sorts of robots, big and small, each unique in their own special way. Robbie's best friend was a tall, tower-like robot named Tippy. Together they embarked on countless adventures, from exploring the depths of the robot city to solving tricky puzzles that left other robots scratching their heads. Robbie's life was filled with fun, laughter, and lots of learning. Now, have you ever wondered how Robbie and his robotic friends come to life? Let's dive into the exciting world of robot making. Robots come to life in a place called a lab, which is just a fancy name for a robot's birthplace. It's not quite the same as a hospital or a stork delivering a newborn, but it's just as magical in its own special way. Imagine you're about to draw a picture or build a towering castle with your favorite blocks. You always begin with an idea, right? Creating a robot starts much the same way. It all begins with a thought, a spark of imagination, a what-if moment that blossoms into the seed of a robot's birth. People who design robots, we call them engineers, sit down with their pencils, papers, and computers and start drawing out their ideas. It's like they're sketching a picture, but instead of a landscape or a portrait, they're drawing the skeleton of a robot. These drawings are detailed and precise, outlining every gear, every wire, and every bolt that will eventually become part of the robot. It's a bit like creating a blueprint for a house, but instead of walls and windows, we have motors and sensors. Just like when you're building with blocks, decisions have to be made about what the robot will do and how it will look. Should it have wheels or legs? Should it be tall or short? Should it have 2 arms or 4? These choices are just as important as deciding whether your block castle should have a moat or a drawbridge. And remember, just like your drawings or block structures, the design isn't always perfect the first time. Sometimes the engineers need to erase, redraw, and rethink their plans. They might have to knock down their block tower and start all over again. And that's okay, because each time they do, they're one step closer to creating a robot that's just right. So, we've designed our robot, what's next? Time to make our design a reality. After designing our robot, it's time to assemble it like a jigsaw puzzle. Think of it this way, each part of the robot is like a piece of a puzzle, each with its own unique place and purpose. Just like how every puzzle piece helps to form a beautiful picture, every part of the robot helps to make it move, think, and even talk. First, we start with the skeleton, or the frame of the robot. This part is like the edges of our puzzle, or the base of a toy brick tower. It's the backbone that holds everything together. It's made from light but strong materials, just like how birds have lightweight bones to help them fly. Next, we add in the motors and gears. These are like the inner puzzle pieces that start to make the picture clear. They're what make our robot move. You can think of them as the robot's muscles. Some make the robot walk, some make the robot's arms move, and some even make the robot's head turn. Then, we've got the sensors. These are the robot's eyes and ears. They let the robot know what's happening around it. Just like how our eyes help us see and our ears help us hear, the robot's sensors help it interact with the world. Finally, we place the brain, also known as the microcontroller, into the robot. This is the final puzzle piece, the one that brings the whole picture together. It's like the captain of a ship, telling all the other parts what to do. It takes in information from the sensors, processes it, and then tells the motors and gears how to respond. Remember, just like a jigsaw puzzle or a tower of toy bricks, every part is important. If one piece is missing or not working properly, the whole thing might fall apart, or the picture might not look right. Now that we've assembled our robot, it's time to bring it to life. Bringing a robot to life is like teaching a baby bird to fly. Imagine you're trying to teach a toddler how to tie their shoes. You'd start by showing them the steps, right? First, you make a loop with one lace. Then you make another loop with the other lace. Next, you cross the loops over each other and pull one loop through the hole. Finally, you pull both loops tight. Easy peasy lemon squeezy. Well, programming a robot is a lot like that. But instead of teaching them to tie shoelaces, we're teaching them to move, to speak, or maybe even to play a game. We use a special language that robots can understand, called code. This code is like a set of instructions that tells the robot exactly what to do, step by step. just like how you might mess up tying your shoes a few times before you get it right. Programming a robot also involves a lot of trial and error. Maybe the robot doesn't move quite the way we want it to, or perhaps it's not speaking clearly enough. When that happens, we go back to our code, tweak it a little, and try again. This process of testing and refining is what makes our robot better and better, just like how you get better at tying your shoes the more you practice. You see, robots are a lot like us. They learn from their mistakes, and they get better with practice. The only difference is that their teacher is a programmer, and their classroom is a computer. And voila! After many rounds of trial and error, the robot finally starts behaving the way we want it to. It moves, it speaks, and maybe it can even beat you in a game of chess. But remember, it's not magic. It's just a lot of hard work, patience, and a dash of creativity. With programming complete, our robot is ready to step into the world. And now our robot, just like Robbie, is ready for its own adventures. Our journey began with a simple idea and a blueprint. Much like Robbie, our robot was a mere concept, a dream waiting to be brought to life. And now it's ready to embark on its own journey, to explore, to learn, and to assist. Robots, like our friend Robbie, are not just creations of our imagination. They are a testament to human ingenuity and creativity. They can accomplish a wide range of tasks, from the mundane to the extraordinary. They can help us clean our houses, assist us in our work, explore the deepest oceans, and even venture into the farthest reaches of space. Think about it. Robots can perform tasks that are too dangerous or challenging for humans. They can withstand extreme temperatures, pressure, and environments that humans cannot. They can aid in scientific research, in space exploration, and in medical procedures. Robots can even help us understand more about ourselves and the world around us. But that's not all. Robots like Robbie are continuously evolving. They're learning, growing, and adapting just like us. With advancements in technology, who knows what they'll be capable of in the future? Maybe they'll be able to paint like Picasso, compose music like Mozart, or write stories that touch our hearts. The possibilities are endless. The adventure of Robbie the robot is not just a tale of a cool, shiny, metallic friend. It's a story of progress, of dreams turned reality, of the limitless potential of the human mind. It's a reminder that if we can dream it, we can build it. And that's how our robotic friends come to life, from an idea to a design to a jigsaw puzzle and finally a new member of our world. Who knows, maybe one day you'll create a robot friend of your own.
New videos every day. Subscribe to our channel.